Hello everyone, my name is Anik. You can just call me Nick. And in today's video, we're just going to be talking about AI computer vision, basically the history about it and what has come up into the latest days, right, of computer vision software. And we're going to actually use something called Google Colab to make our own type of software with using TensorFlow, which we'll discuss in the video. So basically, with computer vision, it kind of began in the 1960s, this idea, specifically in the MIT, where Marvin Minsky basically tasked his students to basically connect a camera to a computer and then like make it describe what it's seeing in active time. And so this became kind of a challenge, right? And no one was really able to do it. And this is where it kind of led to this idea of visual input, right? This is where the computer is able to pick up information and data from its surroundings based off of a visual inputter like a camera. So honestly, it did take a lot of time for this type of visual input and then output back to us to come about. And this is kind of where the idea of image processing began. And you could see that later in the 1970s, 1980s, is when people, like specifically researchers, began recognizing that there are specific shapes and patterns and specific motion that the camera must pick up, and that the AI model or the whatever model that the machine specifically must understand in order to interpret, okay, that right there is a cat or that over there is a computer. So it really, the core of it is that it relies on data and it relies on pattern recognition. And so in the 1970s and 1980s is when they kind of defined the setbacks and the problems behind these patterns and motion and other issues that may come up with video, with capturing video and capturing pictures. And in a mathematical sense, in the 1980s, they were able to do the following, right? Edge detection. They were able to detect, okay, that part right there is that one side. This is another part of that object or that block or whatever it is. And another thing is optical flow. It's also do other analysis in order to interpret, okay, that over there is a speaker, that is a computer. So it took a long time, but then the industry kind of froze. This is what they call the AI winter. It kind of started in the 1970s, went up all the way to the 1990s, which is considered the second AI winter. And basically, there wasn't much funding given to the AI field. There was a lot of research being done, but even then, that was kind of slowed down. Um, Also, because this is during the Cold War. The Cold War is about to wrap up during this time in the 1990s. The early 1990s is when it ended. And so it was kind of slow. People were building back after the Cold War, after the 1990s. So there wasn't much funding going into AI, and there's more funding going into war. Now, if this page can load, there we go. In the 1990s is where, later in the 1990s is where geometry and statistical models were created. Specifically, you can see right here on the left side this model where they created this like camera thing right here, and this basically was able to do a lot of geometric analysis, specifically by taking 2D images and kind of creating a 3D structure digitally, which is pretty impressive during its time. And eventually, there was something called appearance-based recognition, which basically used statistical models to kind of, uh, you know, understand and detect, okay, that object, I'm, 55% confident it's a computer, or maybe 20% confident it's a tablet, right? So there's a lot of statistics behind image and like face recognition, all that. That's more modern, but face recognition too, it kind of relies on this idea of statistics in order to approximate and detect, okay, that person right there, that's Onik, or that's Nick, or that's someone else. So it does rely on a lot of statistics. And then eventually there's, right, and this is kind of more modern, with digital recognition, where it's able to use it in banking scenarios. If you were to deposit a check, or do anything else with that, then it's able to detect, okay, this is a valid check, it has the person's name, this is how much money they're trying to send to this person, and then who signed it, has the signature, has the date, has all the other information, right? So that's with that information is able to like either do the transaction, carry out the transaction, or reject it and say, hey, sorry, there's something, an error popped up. And so that's something that AI, video and camera recognition is able to do in today's society. And then in the 2000s, we're going to go a little bit back. In the 2000s, we did have more generic recognition, specifically with SIFT. Now, SIFT, it was reliable to an extent. It could do a lot of things, right? It could do image matching. It could pair two images and say, okay, that image is pretty similar to the other image in these senses, right? And then there was something called Viola Jones, and this is a machine learning kind of algorithm that was developed in 2001 that could do face detection, right? And so this type of face detection, especially after, during this time period, was after 9/11, they started implementing those type of face recognition into airports and into security. So that's what they did to avoid any other, any things going on and any problems going on in the airport or on the planes. So, and just overall, just make it more safe and secure for other passengers. And then there are also some data sets that people have created. Caltech 101 is one of the famous ones. It has, I think, over 8,000, 9,000 images of random things, right? Like watches, people, other items. And you can use that and also Pascal data set. These are both on Kaggle, by the way, which is Kaggle is just it has all these data sets that you can access. And so Caltech 101 and Pascal are two data sets that you guys can use for like large scale labeling, so that the AI model can basically take those images and kind of label, okay, that's a cat, or that's a dog, or that's a human being, or that's something else. And then with that data, if you were to give it new data, that's something that is never seen before, then it can give you some confidence. It's to say, it could say, based on what it's been trained on, which has been trained on Caltech 101 or Pascal, then it's able to say that thing right there is a human, or that's a computer, right? So it's basically used for pre-training. And then this is kind of where the big explosion occurred, I would say, 2012 with AlexNet by Alex Krzyzewski. Now, Alex Krzyzewski, he created something called AlexNet. He named it kind of after himself. He didn't really want to take credit for it. He was more of like a shy guy. He just wanted to work on the project with his group, but he didn't really want to release it. He had two other like members in his team who kind of did want to do that. And so they named it after him. He was the coder who made it. And how it worked was that AlexNet was a kind of convolutional neural network. It was an AI model specifically that used GPUs in the GPUs stand for graphic processing units. It took GPUs and put them in parallel. And so if you put the GPUs in parallel, they work a lot faster and they're more efficient. And so it was able to identify and classify images way faster than other models at the time, other image recognition models and other convolutional neural networks. And so this term convolutional neural network just a term that kind of refers to an AI model that can classify images, and it has specific layers in it, like specific, you can call them steps, but we call them layers. And these layers can go from taking input data, processing it, and recognizing patterns, and then outputting some output that maybe it's a visual output, an audio output, a text output saying, okay, that's a cat, or that's a dog or whatnot. And so it was way, way better than other models because it was so efficient. It used GPUs in parallel. And so this was kind of the paradigm shift, I'd say, is where it was able to take, massive computation. No, it had lots of, it had massive computational power, and it was able to take big data in order to transfer, computer vision and all that to another level, where it was able to create these kind of um, connections and recognizing patterns way easier and way faster than other AI models at the time. And so yeah, CNNs, if you need a little debrief, is just that it's used for classification, for detection and segmentation of all types of images and videos and whatnot. And so now, if you look a bit more recent, 2015 to 2020, there's more models that are created. ResNet. There's also ResCNN. There's EfficientNet, VGG. These are all other models that were created that are kind of descendants off of AlexNet. And these models can be used in research labs, right? Specifically for autonomous vehicles, right? If you want to make, like, for example, Tesla, right? Tesla kind of uses one of these CNNs, many CNNs actually, in order for them to navigate the car safely if you were to put it on autopilot. And then there's also medical imaging, right? It can detect certain cancers or certain problems, diseases in the person's body. And then even in smartphones, there's other photo detections that are, or camera, computer vision detection software that is there. For example, if you're on your iPhone or even Android, there is on your phone, on your photos, you could see that, like, the AI model is able to detect, okay, this image is taken at this location at this time, and it's it gives you some more information, like who is that person. Maybe it's me, maybe it's my mother, maybe it's my friend, right? And so it's basically able to create metadata. Now, metadata is literally just the data of the data. That means that, like, it's the data of, for example, an image, right? That basically means that the metadata of an image would be like the person's name, where was it taken, right? Other information about the data of the image, right? So it's basically creates all this metadata. And then there's systems like YOLO v4. I think there's version 5 even today. And then there's faster RCNNs that can really do a lot of object detection, and it's used in practical senses like robotics or across all high schools, even middle schoolers do it, and even in real world industries, right? In robotics and all types of robotical engineering and all that. So that's where you would see YOLO v4 and RCNN. And then now we have these more current things today, our vision transformer, which is VIT, and this is kind of beyond CNNs, right? This goes like one step above that. It's able to basically leverage global attention mechanisms to capture long range context across entire images. That basically means that it's able to, take all these different inputs, whether that's a camera, whether that's audio, whether that's text or all that, and then it's able to create a kind of background, like it's able to create a story almost. Okay, like what are all these images kind of, what are the similarities, what does it represent entirely? Maybe it represents, let's say you were to put images of a party, right? Maybe it's able to describe, okay, John and Bob went to a party, they had fun, they went bowling, maybe they talked with some friends, right? So these images are able to kind of create that story. And then we have more of generative AI, where generative AI, right, DALL E and Sora, which doesn't work anymore but used to, were created for creating new images, right? ChatGPT, it owns DALL E, and you guys can use that to create any image that you want, or even identify any problems within the image. And there's multimodality, and this is kind of similar to VIT, where it's able to take in more inputs, right? Pixels, audio, even at complex things, the most complex things like language. Language is super complex. They have such a each word has such a unique definition and meaning that can't be kind of fully understood by an AI model, but they have done the best as they can in order to kind of replicate that. And then beyond just seeing, it's also understanding and reasoning, right? It's understanding the context. Like if you're doing surgery, as you can see right here, it's understanding, okay, what part of the body are we trying to fix up, right? So in this case, I think they're doing the chest or something right here. What are we trying to do? What are we trying to interpret? And it's all able to do a lot of reasoning in order to understand various complex environments and various changes in the environment in order to adjust to uncontrolled settings. And so yeah, there's real world stakes, right? Life saving medical diagnostics, whether that's recognizing certain cancers, certain diseases, certain maybe diabetes and all that. So there's some practical uses of these AI models and computer vision itself. And so yeah, the future isn't just that it can just see, it's also able to take action and do stuff, right, with these autonomous agents and models. And these you can actually create robots with these if you have a computer vision software integrated into them in order to explore, make scientific discoveries, and just overall be an intelligent figure in society. As you can see in this image, you can see two robots right here who are just kind of interacting, looking around the society, and maybe taking action, maybe going on a bus, maybe doing something else. And that's the end of this presentation, but let's go on to the actual software. So what you have to do is you have to go on to Google Colab. And if you go into Google Colab, you'll see this, welcome to Colab. And then you'll just need to create a new notebook right here at the bottom left. And then when you click no notebook, you'll see this, but it'll be all empty. And on your right, or even at the bottom, it'll show like a Gemini symbol. You can click on that. I'm pretty sure you get it even on the free version. You can still have access. You can put in the comments if that's not true, but either way, you guys can open up Gemini or ChatGPT or Claude on a separate tab and copy the code from there. But basically, I just asked it, create an AI computer vision software, show demo, and add comments to explain the code so that it's easier for me and you to understand what the code is doing. And so it took some time. It took a couple of minutes, and here it is. So you use TensorFlow, right? TensorFlow is one of the most commonly used, AI models for classification and for running AI models and for classifications of images and videos. And then, so it was also able to use Matplotlib, right? This is for the visualization part. And so here it imported all the necessary libraries and files that it needs to kind of understand the images. It created the model. This is the command that it used for it to kind of create this mobile net v2, which is CNN. And then it's able to, we just put a sample image right here of a cat. And then this is basically from a look at these cat images, right? But it's able to take images from there and then create it into an array, and then the array is able to, it basically takes an image and it dissects it in like little chunks, and then the image is able to be put into the AI model, the CNN, the convolutional neural network. And then this CNN is able to it goes under certain layers that we can talk about in a different video because it's very complex, but it goes through certain layers, and then it's able to identify, that's a cat, and then it's even able to identify the breed, right? Like maybe that's something like, I don't know many breeds of cats actually, so I couldn't tell you, but let's say for a dog, maybe that's a golden retriever, maybe that's a poodle, right? It's able to identify certain dogs or cats. And then right here is able to make the prediction, and you can see that this is the original image that was fed into the AI model, and it was able to the top prediction was a tabby, And then no, you can see that if it's closer to 1, that means it's more confident that it's it's that certain breed. So it's 57% confident that's a tabby, and then 33% it's a tiger cat, and then 1% Egyptian cat. So it's less likely to be an Egyptian cat, more likely to be the other two. And so you can use this for other scenarios, right? If you want to use one for dogs, or if you want to use one for certain scenarios. I don't know, maybe for facial recognition, right? You can put it, I don't know if you'd want to, you have to be careful with stuff like that, but if you want it, like, you consent to it yourself, and you ask consent for other people, then, and they say yes, then you could put their images and your images into this AI model, and then it's able to recognize, oh, that's Nick, or that's what someone else, that's my friend, or that's someone else's friend, right? So that's something that AI has been able to do. So if I were to rerun this, actually, you can see that it'll pull up a new image, and then it's able to detect, okay, that right there might be a tiger cat, or maybe that's an Egyptian cat, or something else. So let's see if it's able to run. And then see, it takes a little bit of time, but look, took this image and it's able to also identify it's a tabby. So it's just really cool what AI can do these days, especially with using software like TensorFlow and Matplotlib to make it easier for you to make the CNNs, these convolutional neural networks, for classification of images and videos. So that's about it for today. I hope you guys enjoyed the video, and thank you.